shop owner has buyed in the Santa or in any Raitu Bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are Polaroids. We are top on the Everest. Congratulations.
I want to be a leader.
Hi Sweros, good afternoon to one and all. I am Manasa Swero of 2nd MPC from Madikonda College. How are you? See, before starting our class, let us recall some basics. We have in our earlier classes, we have already learnt what is physics. Do you remember? Yes, physics is a branch of science which deals with nature and natural phenomena. But is it true? Let us prove it today itself. In general, if we find days as well as nights. But what is the difference between a day? What differentiates a day from a night? Yes, it is only the presence of light. What happens if light is absent? Yes, there is no life on this earth without light. But do you know what a light is exactly? Yes, light is a natural form of energy which makes things to visible. It is a transverse wave and an electromagnetic wave. See here Sweros, here is a picture of transverse wave. See, here it is clearly shown, and the light rays which are coming from the sun are shown here clearly. So, see, think, you are on this earth. If the rays which are coming from the sun can be seen by you directly, what happens? You can't able to see other objects clearly for 2 or 3 minutes. Is it right? Yes. Why it happens? But now generally you are exposable to the natural light. Yes. Then what is the difference of that light? Why you are not able to see that light but you are able to see this light? Is there any difference? Yes, Sweros, there is a difference. The light ray which is coming from the sun is unpolarized, whereas the ray which we are seeing is a polarized light. What is an unpolarized light then? Before knowing about an unpolarized light, let us see how a light travels actually. I have said you now, light travels in a transverse nature. See here, Sweros, light, this is how a transverse wave looks. Its direction is towards x-axis, whereas its vibration is towards y-axis. Have you seen it clearly? Yes, Sweros. The light travels in a transverse nature. Then the light rays which are coming from the sun is unpolarized. Unpolarized light is nothing but a light ray which vibrates in more than one plane. It means there is no particular direction for the rays which are coming from the sun. So here, Sweros, here is a picture of a light ray which is coming from the sun. Due to the molecules and the atoms present in the atmosphere, this light can be splitted into many rays. That is how an unpolarized light looks. But what is the natural light which we are exposable? Yes, it is a polarized light. A polarized light is nothing but a light ray which travels in a single plane. It means a light ray, it may travel in a vertical plane or it may travel in a horizontal plane. See, for example, this is x-axis whereas this is y-axis. A light ray which is coming from the sun can travel in any direction. It may be horizontal and vertical. But a light ray which we are exposable can be seen in a single plane. Either it may be x axis or it may be y axis. This is how a polarized light looks like, and this is how an unpolarized light looks like. But what makes this unpolarized light transmits into polarized light? There are many methods in our physics, not only in physics, in general life, which makes an unpolarized light to transmit it into polarized light. What is that? It is nothing but a Polaroid. A Polaroid is a chemical substance which makes unpolarized light to transmit into a polarized light. How it looks like? Let us see here. See, this is Polaroid, and if you see it clearly, these rays are unpolarized, whereas these rays travels through a Polaroid, then they vibrates in a single plane. Polaroid makes unpolarized light to absorb it. A Polaroid absorbs an unpolarized light, and it just allows only one plane to come out from the Polaroid with decrease of the intensity. It means a Polaroid decreases the intensity of the actual light coming from the sun. If we place a single Polaroid, half of the intensity will be decreased. Then think, if we place more than one Polaroid, what happens? So here is a slide, can be seen. See, the scientist is Malus. He have given an equation if in case more than 2 Polaroid has been placed, I equals to I naught cos square theta. Here see Sweros, there are 2 slides here. In the first case, according to the equation of Malus, 2 Polaroids are placed, whereas first Polaroid, unpolarized light is transmitted from first Polaroid with less intensity, and it is transmitted to the second Polaroid, which even decreases the intensity of the light, and here these 2 Polaroids are placed parallelly, and then it means it proves that the angle between these 2 Polaroids is 180 degrees. It means here I is greater than I naught. I is nothing but intensity of first Polaroid, whereas I naught is nothing but intensity of the second Polaroid. I is greater than I naught, then I equals to I naught cos square theta is the equation of Malus. Here theta value is 180, as these 2 Polaroids are placed parallelly, then cos 180 is minus 1 whole square is equals to 1. It means I equals to I naught. I equals to I naught proves that these 2 Polaroids allows, the second Polaroid allows some light comes out with less intensity compared to the first Polaroid. But see here Sweros, here is the second case. Here the first Polaroid is placed parallelly, whereas the second Polaroid is placed perpendicularly. It means the first Polaroid allows horizontal plane to come out, whereas the second Polaroid stops the horizontal plane and it does not allow any light to come out. That is what here it is cleared. And see Sweros, as I have said you that second Polaroid is placed perpendicularly to the first Polaroid. It means the angle between these 2 Polaroids is 90 degrees. So if you see theta value is 90, cos 90 is 0, so I is equals to 0. I equals to 0 means there is no light coming out from the second Polaroid. This is what here Sweros experimentally proved. See Sweros, here consider it as the first Polaroid, and how does it looks? It is just like a transverse wave. This is a transverse wave. If you take a single Polaroid, this Polaroid can pass these transverse wave horizontally, or it can pass vertically. It can pass in any direction. Whereas if you take 2 Polaroids, see here Sweros, we have placed these 2 Polaroids parallelly. It means the first Polaroid allows only horizontal light to come out, whereas second Polaroid is also placed horizontally. It means this light ray even comes out from the second Polaroid. Is it clear, Sweros? Yes. See, but if you rotate the second Polaroid perpendicularly, what happens? The first Polaroid allows horizontal plane to come out, whereas the second Polaroid stops this horizontal light. It means no light comes out at an angle of 90 degrees between these two Polaroids. Is it clear, Sweros? Yes. Now you have, I think you have a clear idea about a Polaroid and how a Polaroid works. But we are doing these experiments. Why we are doing this? It is because to know how an unpolarized light can be transferred into a polarized light. Is it? Yes. Then what is that process called? The process unpolarized light transmitted into polarized light is nothing but we call it as polarization, what we are going to discuss today itself. The process of transforming unpolarized light into polarized light is called polarization. Then now we have did an experiment by taking two artificial Polaroids. But just think in general, apply this to your general life. You are seeing this normal light, but the sun rays which are coming, the rays which are coming from the sun can't be seen by you because it consists of high intensity. Then how you are able to see this normal light? Is there any Polaroid placed in between the sun and the earth? No. But then how this polarization process is going on in the atmosphere? That is what due to many phenomenons this happens. See, let us see, there are 5 phenomenons according to the wave nature of the light. 5 phenomenons has been given which happens naturally, which makes an unpolarized light transmits into a polarized light. Those phenomenons are polarization by scattering, let us see one by one, Sweros. Polarization by scattering. Have you heard of the word scattering anywhere? No. Scattering, it means when you wake up early in the morning, when sun rises, when you open the window of your doors, what can you see? The light coming from the sun. Is it right? Yes. The light which is touching the edge of your window splits into many rays, many component rays, which can be seen clearly in the early morning in your house. Why it happens? A single ray touches an edge and splits into many component rays. That is called scattering of light. Then how polarization by scattering happens? See, in this atmosphere, millions of molecules are present. Molecules consist of nothing but electrons, protons and neutrons. So, the light ray which is coming from the sun, when touches a molecule, when it is incident on a molecule, then the electrons present in that molecule absorbs the intensity of that light and radiates other half intensity of light in different directions of in the nature. If a ray radiated by the molecule is exactly perpendicular to the incident ray with 90 degrees of angle, that ray is called completely polarized ray. Whereas other rays, they may be less than 90 degrees or they may be greater than 90 degrees radiated from the molecule, that rays are linearly polarized. Let us see here, Sweros. Here it is clearly shown. See, the rays, here is the sun, the rays which are coming from the sun incident on the cloud and splits into number of rays. This is called scattering phenomenon. Whereas here in this slide, an unpolarized ray, when incident on a molecule, this molecule split absorbs half intensity of light and just it radiates other half in different directions. See, in different directions this ray is incidented, but the ray which is exactly perpendicular to this incident ray is polarized, whereas other rays are linearly polarized. Is it clear, Sweros? Yes. This can be applied to our daily life. In daily life situations, not only in the atmosphere where it is top of the sky, it happens on visible light which can be seen by us in the nature. Here, Sweros, here are some examples. If you see it clearly, the light here in the space, many molecules are present, and the light ray touches all the incident on all the molecules and splits into number of component rays. These are all the phenomena. Whereas, if you see here, in your daily life it happens, a light ray which is coming from the window is in a single light ray incident on the window and splits into many component rays, which is called scattering. Even this scattering happens even when the light incidents on the trees or any objects which can be seen. And here also in the nature you can see it clearly and from the window of your house. This is how a polarization actually works. For this phenomenon, a great scientist called C.V. Raman has awarded a Nobel Prize in 1930 for his great work on this phenomenon. See here, Sweros, this is how he got a Nobel Prize in 1930 for his work for scattering of light molecules intensively investigated by C.V. Raman, and was awarded Nobel Prize for physics in 1930 for his work. Have you got a clear idea about polarization by scattering, Sweros? Yes. Then, if a light ray escapes by incidenting on this molecule, if a light ray which is coming from the sun escapes from all the molecules and it just tries to come to the ground, what happens? How does that ray get polarized? There is another phenomenon which is called polarization. Polarization by reflection. Have you heard of the word reflection, Sweros? Yes, I think some of you. But see here, I will give you a lively example. When you wake up in the morning, what you will do? At first, you will go to a mirror. Is it true? Yes. See here, Sweros. Here is a mirror and I am seeing that mirror. It means my face image is clearly shown on the mirror. Why it is happening? The light ray which is coming is incidenting on my face, and as my face is a non-transparent body, it is incident on the light. It means the light here, see Sweros, here it can be seen clearly, my face is incident on this mirror. It is because the light ray which is touching an opaque body is coming back and reflecting incident on this light. It clearly proves that a light ray when touches an opaque body comes back. It means coming back of that ray is called reflection. See, if you observe polarization by reflection, how it happens in the nature? There are many phenomena which shows polarization happens in the nature by reflection. For example, if you see when a light ray incident on water, what happens? We all know that water consists of many molecules which oscillates continuously. Is it true, Sweros? Yes. The molecules which oscillate continuously absorbs half amount of light and they emit half amount of light. It means, see, if this is the surface of the water, the light ray which is coming from the sun touches this surface. As here the molecules are oscillating, half ray is absorbed and half ray is emitted by these molecules. It means this light ray is reflected in this phenomenon with an angle. This is a normal. If this reflected ray is exactly perpendicular to this observed ray with an angle of 90 degrees, then this reflected ray is called polarized light. Whereas here, if this is a normal, if its angle is exactly 57.2 degrees, then this angle is said to be Brewster angle, what we have learned. Brewster angle is an angle which is made by the incident light is exactly 57.2 degrees to this normal, then this reflected light gets polarized, whereas this angle is called Brewster angle. Is it clear, Sweros? Let us see it lively. Here are some examples. See, reflection. These are the non-metallic substances, whereas when a light ray incident on this non-metallic substance, then it gets reflected. It means that the light ray which is reflected from non-metallic substances are unpolarized because any metal does not decrease the intensity. Whereas, see, here in this case it is water and a road and snow fields. You can see it clearly. The light ray which is coming from the sun, which is incident on this water surface, is reflected. It means here reflection takes place in non-metallic substances. Is it clear, Sweros? And see, this is how the angle looks. Incident ray is equal to the reflected ray with a normal in between this. You can take a mirror or a water, anything else. It should be a non-metallic substance. Is it clear? Then, even if a light ray escapes this phenomena also, what happens? See, there is another phenomenon which is called polarization by refraction. Have you heard of the word refraction, Sweros? Yes, I will show you how refraction exactly looks like. See, Sweros, here in a beaker, half of the beaker is taken by water. It means this is air media. It means all this is covered with air. This is air media. Whereas this water is a denser media. It is other media. See, if a substance, how does this pen looks like? It is in a straight line. If this is placed in this water, what can you find, Sweros, here? A slight bending is shown here. Is it true? Can you able to see that bending? But see how it looks like. It is a straight line. Then why does this bending takes place? That phenomena, a bending of light ray when it travels from one media to other media, is called refraction. It means, see, if this is the surface, this is the light ray coming from the sun, this is air media, and consider this is a denser media. The light ray which is entering from air media to a denser media will make the light to bend a little. This bending, here you can find a bending. This phenomena is called refraction. Then, how polarization by refraction takes place? See, we have seen many people who are swimming in the swimming pool, right? Can you see his image as it is according to his body shape? Is it possible? No, it doesn't, because the light ray which is coming from air media, when touches a denser media, then the light ray makes his image to see a slight bending. Let us see here. Here is a slide shown to you. See, Sweros, here refraction takes place in two phenomenons. Here is a water bottle, a hole is made to a water bottle. When a light ray is incident on this bottle, this water is bending slightly. Along with the water, this ray also bends. How? Why it happens? Because the light is moving from one media to other media. While, see in this picture what I have said you now, here a man is swimming, whereas his image is a slight bending is shown in his image. This is happened due to refraction, because a light is travelling from one media to other media. See, here, see Sweros, now you have got a clear idea how a refraction takes place. So, if a light ray escapes from the atmospheric scattering, then it comes and there by the reflection it gets polarized. Even a light ray get escaped from that reflection also, then it can be polarized by using a phenomena called refraction. Even then, if a light ray escapes that phenomena also, what happens? There is another phenomenon called polarization by double refraction. Polarization by double refraction. We have learnt about the phenomenon refraction just now. Then what is double refraction? What I have said you now is, if a light ray bends, then this phenomena is called refraction. Double refraction means here bending should be double. Yes or no? Then how? A single ray is there. How does it bend doubly? See, a light ray in some crystals like quartz or calcite, this phenomena takes place. Even a transparent body called water also makes this phenomena to see clearly. See, consider it as a water media. When a light ray touches the water molecules, here this light ray gets splitted into two rays. One is exactly horizontal to this incident ray, whereas the other ray is a little bit less than the angle of the original ray. It is here where this angle is 90 degrees, then this ray is said to be polarized and this ray is said to be linearly polarized. This can be seen here. Here is a slide. Here we can see it clearly, Sweros. Here a man is fishing. His fish god is put into a water where the light ray makes that god to split into two images, which makes confused to a fish and it gets catched by the fisherman quickly. That is how a fisherman quickly catches the fish by his fish god. In case of a calcite, see here Sweros, here is a calcite, a light ray which is incident on this calcite is splitted into two rays. One is exactly perpendicular and one is less than 90 degrees. This perpendicular ray is polarized, whereas this ray is unpolarized. This happens in only few crystals, and here there is a small experiment. If you take the slides and arrange them by an angle of 37 degrees one by one, if an unpolarized light ray is incident on the first slide,